This video is graphing ratio tables, page 59. Graphing ratio tables. Sometimes we can use graphs to help us visually represent relationships between two numbers. Okay, so I want you to write that. Graphing can visually represent the relationship between two numbers. Okay, so let's do an example here. Let's say we are comparing cost to create CDs. Okay, so when you have a ratio table, you're comparing two items. Well, here we're going to be comparing cost to the number of CDs you can make. So let's draw a ratio table here, and we can draw them sideways. So we're going to write number of CDs and cost. And then in parentheses, I'm going to put dollars, so I know what unit of money I'm talking about. So we have this is going to be the x-axis, and this is going to be the y-axis. Okay, well, the relationship I know is 1 CD costs $3. Okay, if I were to do 2 CDs following that same relationship, this is times 2, so I'm going to times this by 2, would be $6. 3 CDs would cost $9. 4 CDs would cost $12. And just to show that we don't have to go 1, 2, 3, 4, let's jump to 6. 6 CDs it would cost $18 following this pattern. So if I were graphing all of these numbers, each one of these makes an ordered pair. So I have the ordered pair 1, 3. I have the ordered pair 2, 6. I have the ordered pair 3, 9. 4, 12. And 6, 18. When you make a graph, there are some very important things to put on there. First thing is you need to write a title for your graph. So in this case, we're going to write cost to create CDs. Okay, then we also need to label what our axes are. Well, over here on our ratio table, the number of CDs is X. So on the x-axis, we're going to write down here lower so that we want to number it. So since this is going by ones mostly, I can number this by 1. So I'm going to do zeros always in the corner. And you have to make sure you number it accurately and evenly. So I can't go 1, 2, 3, 4, 6. If this is 1 unit, then everything needs to be 1 unit. So 1, 2, 3, 4, 5, 6. Even though 5's not over here, I need to put it on here if I'm going to label these by ones. 7, 8, 9, 10, 11, 12. Okay, now we can number by ones. We can also skip count, but if we skip count, we have to do it accurately. So if I want to go this direction, I want to get up to 18. I don't have 18 spaces here, so if I were to number by twos, that would be okay. But I also need to label this. So this is the number of CDs. And this would be cost. Okay, so if I want to number by twos, I can do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, this is scaled by 2 and this is scaled by 1. On a graph, we can do this. But you have to make sure that you're reading it carefully. If I want to go to 1, 3, I'm going to go 1 CD and 3. Since 4 and 2 are what I have labeled here, I have to find 3, which would be halfway in the middle. So that would be 1, 3. Zoom into that a little bit better. Okay, our next point, look at your table, was 2, 6. So I'm going to go to 2 CDs. Up to $6. 2, 6. Make that a little clearer. There we go. Okay. Next one we had was 3, 9. So 3 CDs. 9 would be halfway between 8 and 10. 4, 12. 4 CDs. $12. Now notice these are all following a straight line pattern. Kind of interesting. Okay, 6 and 18. I could draw a line straight through those if I wanted to. Okay, so, oh, create. I need to fix that. Create, there we go. Create CDs. Okay, so that's how you graph a ratio table. So I'm not going to spend quite so much time on the details. We're going to practice a couple more. Sometimes we can graph 2 ratio tables on one graph. If we're trying to compare the same thing, but maybe comparing 2 different people, sometimes you might graph them in 2 different colors, which is why I'm going to graph one of mine in red pen and the other in black pen. Okay, and also sometimes our ratio tables might be vertical. This one was horizontal over here. We can have them vertical. So here we're going to be comparing 2 different things. Let's say we're trying to see who can do something faster. Okay, we're comparing 2 workers. So we're going to compare Scott and Jeff. Okay, let's say they both work at the bakery. Scott can takes him 1 hour to make 2 cakes. So we're going to be comparing cakes and time. In hours. Say they're frosting cakes. So let's call this one cake decorating. Let's give this one right now a title of cake decorating. Okay. Jeff. Let's do cakes in hours. So he can do 2 cakes in 1 hour. So if we were to follow that, if he had done 4 cakes, that means 2 hours would pass. 6 cakes means that 3 hours would pass. 8 cakes mean that 4 hours have passed. Looking at Jeff, let's do him in red. He can do 3 cakes. First, my pen's not working. Just a minute. Good morning. I'm trying to do a video. 3 cakes in 2 hours. So he could do 6 cakes in 4 hours. 9 cakes in 6 hours. And 12 cakes in 8 hours. So let's graph them over here. First of all, we have our x-axis and our y-axis. So on our x-axis, we're going to label that cakes. Our y-axis is going to be how many hours, because that's how our tables are set up. These ones look like something we could label by 1, so we don't have to skip count or anything here. So 0 is always in the corner. Okay, you have the information over on the right. I'm just zooming in so you can see the graph better. So if we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We can do the same thing on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So let's first do Scott. We're going to do his in black. So he can do 2 cakes in 1 hour. He could do 4 cakes in 2 hours. He could do 6 cakes in 3 hours. 8 cakes in 4 hours. Okay, now looking at Jeff, he could do 3 cakes in 2 hours. He could do 6 cakes in 4 hours. Could do 9 cakes in 6 hours. And 12 cakes in 8 hours. Okay, just so we can see this one a little farther, we only did 4 here. We can do 4 here. Let's do 10 cakes in 5 hours just to show. 10 cakes in 5 hours. So following this pattern. Now if you were reviewing which guy got to keep the job and which one had to go, and you're the employer, it would make sense for him to look at who was making cakes fastest. But also, they have to be quality work. Maybe this guy is not doing as good of work. Maybe you can get them done faster, but not doing as good of work. However, let's say they're both achieving the same type of work. Then which guy would be the most profitable to leave on the team? Well, it would be Scott, because he is making more cakes faster than this guy. This guy takes 8 hours to make 12 cakes, whereas this guy could do 12 cakes in 6 hours. So this is where you would use a graph to help you see that. Okay, I know there's a third graph on there, but for time and space, we're just going to stop there. So your paper should look like